Hi guys, we are going to continue our level 2 organic chemistry 2018 examination paper. We are going to look at question 2 for this particular video, and like always, a large proportion of my viewers aren't subscribed to the channel. If you enjoy the content and if you want to support the channel, please subscribe, leave a like, and let me know if you want me to cover any other particular year levels examination paper. But let's get on with this question 2. Question 2, right. So we got 2 bottles of different colorless organic liquids are labeled. They're known to be propyl-1-amine and ethanoic acid. How could you identify using only sodium hydrogen carbonate? Okay, so the key thing is you have a carboxylic acid, then you have a carbonate, and then you should remember from year 11 science, acid plus carbonate give you salt, water, and carbon dioxide. Okay, so because the this is the ethanoic acid, it's an acid, you need to do we need to write a formula? No, well, I'll just write a general formula then. Acid plus carbonate give you salt, which is not the thing we're looking for, water, which is not the thing we're looking for, and carbon dioxide. So carbon dioxide will appear as fizzing gas, and that's how you know you have a carboxylic acid. Whereas amine is a base, carbonate is a base. Base doesn't react with the base. So let's have a look at the answers. Let me scroll down. So ethanoic acid is an acid, so react with the carbonate to produce carbon dioxide gas. It's a neutralization reaction, so you see fizzing. Okay, and you see a the propyl-amine is a base and will not react. Okay, next one, give the structural formula and name for the product of the reaction between propyl-1-amine and ethanoic acid. That's where the answer was for the last sentence just above, but we can just ignore it. So this is an amine, this is a carboxylic acid. Now just remember that again, I mentioned this previously in my other videos, all branches of chemistry are related. So as an acid, they donate an H. So what's going to happen is that this hydrogen that I highlighted will be donated to the base. Base are hydrogen acceptors or proton acceptors, so they receive the H plus, and then that's why you will get CH3, CH2, CH2, and H3 plus, and then plus CH3, COO minus. And this is the thing you need to understand with organic chemistry. It is only the functional group that will react. Okay, so it's only the function group, so these carbons don't do anything. You just copy them down as you would. So what's going to happen, you have a positive ion, you have a negative ion, and then the salt you produce is going to be CH3, COO, and then this minus, and then the plus from the ammonia will be connected like this. Now to give you guys a simpler thing, let's say instead of using this, what if I react the carboxylic acid with, let's say, with something sodium? Okay, actually I don't want to confuse you too much, let's just ignore it. Okay, you literally just put the positive ion, negative ion together. I don't want to do too much because I think that might confuse you. All right, next one. You got 3 more labeled, 3 more unlabeled bottles. Jeez, they suck at labeling things. And they're known to contain hexane, which is an alkane, hexane, which is an alkane, ethanol, which is an alcohol. Write the procedures to identify each using only bromine water and water. That's enough. Explain any observations. So bromine water is the most useful what do you call it, reagent to distinguish alkanes, alkanes and alkanes. This is what you use bromine water for, because if you have hex-1-ene, hex-1-ene is this is hex-1-ene. If you plus bromine water, you are going to make C, 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 and then the 2 bromines will be added onto the two carbons. You can do the H's, I can't be bothered. So just make sure every carbon has 4 bonds. But the key thing is that there's no reagents required. This bromine water here, this is orange or brown, and then this will undergo a color change from orange to colorless straight away. Okay, so this is a very fast reaction. Okay, so this color change occurs straight away, very fast, straight away. Now if you have an alkane, the alkane, now in this case we are not given UV light because they didn't specifically say UV light normally. Now I'm going to do it here because it's probably not appropriate to talk about it here. If you have an alkane, let's just put hydrogen here because that's going to be substituted. If you react with Br2 and then UV light, what's going to happen? You keep everything else the same, and then the H is swapped with the Br, and the other Br from here pick up this hydrogen and they become HBr. Now this, you must have UV light as a catalyst in order for this reaction to occur, and this also goes from orange to colorless, but this is very slow. This takes a few minutes. It takes, like, say 5 minutes, for example, under UV light. So you must have UV light. Now in this case they didn't say UV light, so this part is not really appropriate. So this is where we have to use water. Now water is a polar solvent, and like dissolves like. So if you have a polar liquid, it will dissolve in water. Hexane is non-polar. How is that non-polar? Because if all the hydrocarbons are non-polar. You know, hydrocarbons are just things with carbons and hydrogens. So the easiest way to remember, all your alkanes, alkynes, all non-polar. But then if you have ethanol which have the CH3, CH2OH, this is an asymmetric molecule. You have significant electronegativity between the carbons and oxygen, hydrogen. This is a polar molecule. So straight away you can tell that your ethanol and your water, they will dissolve each other. And then how would you see that? So you will observe one layer. They'll mix it together. You'll see one layer of liquid. If you put the water and hexane together, you will see 2 layers because they do not mix. Okay, so that's how you can use the observation to talk about it. Now, if you were to use bromine, now I just quickly browse a marking schedule just now. If you went to say like use UV light, this allows you to do it. In that particular year, they wouldn't have punished you, but it's always good to know the solubility stuff. Just remember, like hexane, hexanine, you know, the alkynes, those are all polar. Non-polar. The polar things are your short chains alcohols, your short chains carboxylic acid. Those things tend to be polar. Okay, so if we look at the answers, and when bromine water is added, it will quickly decolorize from a red brown color into colorless. And this is a dish reaction. Now there's no color change with hexane or ethanol. However, if with hexane, if you say adding UV light, if you put the solution under UV light, it will actually undergo the color change in about 5 minutes. Okay, but when water is hexane, ethanol, you see 2 layers with hexane because it's non-polar. There will be no mixing, no attraction. If you still have trouble doing the solubility stuff, refer to my 2.4 videos where I spend a lot of time talking about the solubility section. So I won't emphasize that too much here. All right, last part. Now, many organic reactions take more than one step to convert from one organic. We need to convert pentan to amine from an alcohol. So we need to make pentan to amine. So why don't we just draw this bad boy first? So this is pentan to amine. Pentan to amine. Make sure every carbon has 4 bonds. Now, how do we turn pentan something into another something into this? So this has to be alcohol. Now, does it make sense this is what I meant before. The carbons and the hydrogens don't tend to react. So the only key thing that changes is that you must have had an OH group on the same carbon. You can see there are 5 carbons here. On the second carbon, I have an OH group. I have 5 carbons here. I have a nitrogen and have a amine group on the second carbon. So that has to be the alcohol. Otherwise, you can't make this in one step. If you have, like, say this, if you have this, like say this is alcohol, how the heck are you supposed to magically convert this OH group from the first carbon and move that to the second carbon? This is impossible. Okay, so this is pentane 2O. Pentane 2O. Now we need to convert pentane 2O to something to NH2, and if you are really familiar with the flow chart, then you will know that you will need to convert this to a haloalkane, which is a chlorine, which is 2-chloropentane. Okay, now next part, elaborate on the reaction in the scheme above. Any condition needed for each step, the name of X and Y, and the type of reaction. Okay, so I'm going to come here. I'm just going to quickly get rid of this. Get rid of these lines, and we're just going to do it here. So to oops, that's not the name. The name is this. Okay, sorry. The name is that. That's not the reagent. So for reagent 1, to convert pentane 2O to 2-chloropentane, you can either use SOCl2, PCl3, or PCl5. Just pick one. I normally go with the SOCl2 because this is more correct, and then this gets used in level 3 as well, whereas your PCl3, PCl5 gets left out at level 3. Now, how do we turn? So how it works is that you're replacing the OH group with the Cl, and this is where the Cl comes from. And now the next part, if you're wanting to replace a Cl with an NH2, so the reagent number 2 must be NH3 alcohol, and now that's how that works. Okay, so the first type of reaction, this is a substitution reaction. Well, actually both of them are substitution reactions, where you substitute the function group with another function group. Okay, so let's have a look at the answers. So both reactions are substitution reactions because only one group is substituted. First step, the OH is substituted by Cl, and then the Cl is substituted by NH2 to make the yep, so it can be substituted to form the amine. This is so that OH group in aqueous, ammonia doesn't. Okay, so you have to do this in alcohol condition. So this is what this part does. Because if you do it in aqueous, I'll just elaborate on this. If you use NH3, if you don't specify alcohol, if you have NH3 aqueous, aqueous means this is dissolved in water, and water can be split into H and OH groups. So this OH group, if you have CC, let's say, where's the CR? Yeah, look like this. If you react with NH3 aqueous, what's going to happen is that instead of substituting this with nitrogen, you actually substitute with OH, so you go backwards. Okay, so that's not very helpful. So this is why the alcohol condition is required. As you can see, it's in brackets, so it's not really necessary. But again, this is flowchart, very basic stuff of organics, and so yeah, spend some time learning it. So again, if you found this video helpful, smash the like button, subscribe if you haven't, and I'll see you guys next time. Bye bye.